Hi, my name is Alexis, and today we're going to talk about scatter and how we can reduce and or control the effects of scatter on our images. First of all, scatter is produced when X-ray beams interact with matter and then they bounce typically off the patient and back into the air. We usually try to avoid scatter in our images because it'll produce a low contrast image and typically a foggy image. As I previously mentioned, we need to avoid scatter in our images. And one of the ways that we can control scatter is by using beam restrictors, also known as collimation. The reason why is because when we collimate on a patient, we limit the area to where the electrons are gonna hit the target. And that helps because those X-rays will interact with the patient, and most of them, rather than bounce off the patient, will be able to hit the image receptor and giving us a high quality image. Okay, one of the biggest sources of scatter is usually the patient, and usually it depends on the patient thickness. Therefore, there are ways that we can try and limit the production of scatter or to reduce it from reaching our images. One of the ways is by using a compression pad or a compression paddle. Therefore, when we press it up against the patient, we're reducing the tissue coefficient, the patient thickness. Therefore, we reduce scatter from reaching the image receptor. So more X-rays are actually penetrating into the image receptor, producing a more high contrast image. The radiographer controls different factors that can help reduce scatter radiation. However, as I previously mentioned, patient thickness is a big factor when it comes to scatter production. When X-raying a thicker patient, higher kVp is used to ensure sufficient penetration. However, using a higher kVp will produce more scatter radiation. Therefore, to reduce scatter, the radiographer uses the 15% rule to compensate and lower the kVp to reduce scatter and improve image contrast. As a radiographer, we understand that there are things that are under our control and there are things that are out of our control, such as patient thickness. You know that when we try to get an image, we want to obtain a good optical density and high contrast. And as previously mentioned, one of the factors is using the right kVp. Another way that we can control and reduce scatter from reaching the image receptor is using a beam restrictor, using the collimator correctly, meaning limiting the sides as to where the X-ray beams are going to interact so that there's not a lot of scatter in the air. And lastly, we also use compression bands in order to limit patient thickness so that we can get a better quality image. There are also other factors that my partner will get into, such as the use of grids. All in all, we understand as radiographers that the point is we need to try and reduce as much scatter, and not just scatter, but reduce patient dose. So we need to try and choose the correct factors and have knowledge as to what we're doing when we're in the room and with our patients. Thank you and have a great
Yarely, and I will be speaking about the grids and the type of grid errors that it creates. A grid is a radiographic device that reduces scatter, and the first grid that was ever invented was by Gustav Bucky. The grid is used to produce a higher quality image, and it's made up of lead strips and an aluminum interspace. It can also be made up of plastic and cardboard interspace. The grid is usually placed between the patient and the IR. Grids are used to reduce scatter, but if you don't use them correctly, you can produce a lot of grid errors. In other words, they're called grid cutoffs. This one for example, is called off focus. It means that there is more SID than there should be. Another type of grid error is called off level. Off level is when you have an angle in the X-ray tube or in the IR. In this case, we have angle in the X-ray tube. So this is how it would look like. Here is the upside down effect. That is when you place the grid upside down. Usually, this part is supposed to go face up. It has the line in the middle, and if you don't see it, it's gonna look like this. If you place it like this, you'll see a strip in the middle. Center error is when you see this tube is not in detent. You must put it in detent to get rid of the off-center error. The error that I will be talking about is the Moray effect. So as you can see, this is the digital system room. They already have a grid installed inside the table or bucket. When a tech comes and places another grid on top by mistake, it will create the Moray effect. That's when you will see a zebra effect on the image. I would like to put the grid errors into perspective for you. This image right here is lacking density on the edges. This is off focus error. Like I mentioned before, this is when you get the wrong SID and there's too much of it. This is how the image will look like on the edges right here. Now I'm going to show you the off-level grid error. As I mentioned before, off-level is when either the IR or the tube, which here it's not shown, is angled. And this is what you're going to get. You're going to get lack of density in the image. So, as you can see, the image looks lighter than what it should be. The upside down grid error is when, as mentioned before, is the X-ray tech will put the grid upside down. So this is the easiest error to notice. You're going to see a black strip in the middle of the image. The next grid error that I will be talking about is off-center. Off-center is when the image is starting to fade in density. So you can tell that it is off-center right here. This happens when the detent in the X-ray tube is not aligned. Okay, the last grid error that I will be talking about is the Moray effect. That is when you see the zebra lines over here. And as mentioned before, is when you put two grids on top of each other, and that's what it's going to create. Now we'll be speaking about the type of grids that we use. This is the parallel linear grid. It's the simplest form of grid, and it cleans up scatter in one way. This is not recommended to be used in a large image receptor or a short SID. The diverging X-rays are absorbed by the edge of this grid. That I will be talking about is the crosshatch grid. This grid is actually two parallel grids that are smushed together and they're perpendicular to each other. There's two different colors so you can tell which is which. This gives you a higher patient dose, and it's the first grid that was invented and used. This grid cannot be used with angulation. The grid that I will be speaking about is the focused grid. This is the grid that we usually use in our tables and buckets. Right here in the middle, it's going to be parallel, and here it's slanted. The reason it's like that is because of the diverging X-ray beams, and it's usually used at distances from 40 to 72 inches. You have to center the patient correctly in order for the image to come out. Good. All these grids can actually be used in either moving or stationary. That means that when you use it as stationary, it's not going to move. So it's literally just like this. You put it down and you can use it wherever. Usually it happens when you're gonna do a mobile X-ray, and then moving grids are when they're placed inside of a table. They're already installed, and that's usually with focus grid. It'll move in a reciprocating movement, which is back and forth, or in an oscillating movement, which is circular. used to reduce scatter, and they should be used with a patient that's 10 centimeters or over. If used properly, you'll get a great image.